Good afternoon, class. Today we're going to try to learn something about cows. We're going to study cows, and we're going to study people, and we're going to study these 50 United States, and we're going to see what kind of patterns we can find about cows. That sounds exciting. Hi Abigail, hi Abby, hi Gracie, hi Cole, Sean, Christina, Cam. Hi everybody. So before we get started with learning about cows, I want to show you something new on Sakai. All right, on the Sakai site. Well, I've put some new items of study here under lessons week 2. Okay, a summary, try to be concise, a summary of where we are and what we should be doing. Okay, but I wanted to show you this, and this is very, well, this is somewhat premature here, but your first lab practicum isn't due for a couple more weeks. Let's look at the syllabus here. So it's scheduled due on, where is it? There it is. So it's scheduled due on the 24th of this month. Right there it is, the 24th of this month. Okay, so today's the 2nd. That's 22 days away when this is due. But I've already posted it. I've posted the practicum on the Sakai site. It's under assignments. Okay, lab practicum 1, and let's see what it looks like under your view. Okay. Okay. So there's an explanation. Wait. Sorry. I didn't change over. There you go. Okay. So under assignments, let's go back here. Assignments. Oh, no, not roster. Assignments. Lab practicum 1. Due date, when it's due, it's 20 points. But don't think about that. This is it's a significant chunk of your grade. But there's instructions, and as you can see, these instructions are pretty general instructions. I'm describing the resources that I've given you to accomplish your goal, and I'm describing the goal that I want you to achieve. Okay, and this isn't a mistake. This is what this is about. Using the skill set that you're developing in class and in lab, you're taking what I give you and producing a result, a map. Okay, and the data I'm giving you is a map to start with, a map package, and 2 data files, 2 tables. And I'm asking you to use this to create a map that tells the consumer of this map something about the prevalence of cigarette smoking in the United States and the prevalence of lung cancer rates in the United States. Do you think there'll be a correlation? We'll find out, okay? But it's worth, this is posted there now, and it would be very beneficial for you to read this, the lab practicum instructions carefully, take a look at the files that I've given you, and to sort of buffer this mission in your brain, because things we do in lab and in class will help you to accomplish the goal of this practicum. Okay, And if you have it in there in your buffer, you're like, oh, I bet I could, this is important for accomplishing that lab practicum. All right? Okay. So let's go to, I guess, my desktop. My busy desktop. Whoa, it's like, look at that. Holy smokes. You're seeing my OBS window inside the window. Wow. Live streams to infinity. All right, let's move that out of the way. What I want to do is I wish I could show I'm still trying to. This is I'm trying to perfect this tech and go back and forth between different sources. But what I want to do is I'm interested in studying cows. I want to know how many cattle there are in the United States. But I'm curious about where they are. You know, what state has the most cows? Which state has the least cows? But let's go a little bit further, because I wonder if there's any states where the number of cows outnumber the number of people. I wonder, and in those states, I wonder what the cow to person ratio is. How many cows there are per person. So if I think about, and as I'm talking here, I'll ask you some questions, and you put some answers in the comments for me. Or if you have any questions of your own, put them in the comments. I'm looking at them here. And let's think about the type of data that we'll need to know to answer this problem. I'll take a note. So what we're doing right now is actually very similar to what you'll do in lab tomorrow for part of the lab exercises. Come on, I'm here. There we go. Let's see if this works. Remote desktop, where did you go? Hello. Huh. All right, 1 second. Yay. All right, so I got my virtual whiteboard here. And I got a new stylus for my tablet. My wet noodle of a pen that I was using just wasn't cutting it, so I got a new stylus. So it works a lot better. We want to study cows or cattle. In the USA. All right, and the things that we want to know are how many cows or cattle are in each state, and something like this. Are there any states with more cows than people? And maybe also, a question like this. What state has the most cows? Okay, so we want to answer questions like this. And so now I got a question for you. you are uh, uh, you are emerging experts in GIS. You are gaining a skill set to apply to solve many different problems, including this one. And the question you need to answer is, what kind of data are you going to have to find in order to answer these questions with the GIS? What kinds of data? And let's say you want to, you want to make a map too. I didn't put that on here, but we want to map things. We want to map answers to these questions. Okay. Let's see. What do you say? Anybody have anything? Look at your comments. Maybe I'll start with a more specific question. Let's say, I want to be able to map the answers to some of these questions. What kind of geographic data will I need in my map? If I'm studying cows and cattle in the 50 United States, what do you think? What kind of geographic information will I need? What kind of feature layer will I need in my map? You guys are quiet today. Nobody? Grasslands? Michelle says grasslands. So maybe there's something else that we could analyze in terms of we could see if there's correlations between where the cows are and the environments that they find themselves in. A hypothesis is there's more cows where there's more grazing land. So we could do this. Cam says, are you talking about dividing it into states? Yes. So I would like to make a map that shows somehow, some way graphically, how many cows are in each state. How many cows are in each state. So what kind of shapes do I need in my map? What kind of geographic polygons, what kind of polygons do I need in my map? I need polygons for the, you're so close. If I want to show something that relates to the states, I need polygons for the, fill in the blank. I know there's not that much of a delay. If I want to make a map that communicates information in some way visually about the 50 states, yeah, Cam's got it. Okay, Cam, I think maybe you're already there. We need polygons for the states. Okay, so the data that we need is, oh, that was weird. We're going to need polygons of the states. Okay, that's geographic data. That's a GIS layer. So this will be a layer in our map. Okay, and when I right click on that layer, I can view its attribute table, which has this is a place that lists characteristics. Every column in the attribute table is a characteristic of each of the rows. Each of the rows, there'd be one row for each state, and maybe you have a column for surface area, a column for the median household income. Okay. Okay. So what kind of uh, data do I need in my attribute table in order to answer questions about cows and how cows relate to people? Well, I'm going to need make that bigger. So we need polygons of the states, and in this attribute table we're going to need to know the population of each state, and we're going to have to, and then that's humans, and we're going to have some sort of count for cows. All right, and let's see, is that all we need to answer these questions? How many cows are in each state? So if we have the geometry of the states and each state has an attribute for the number of cows, we could communicate that. How many cows are in each state? Are there any states with more cows than people? Well, if we know how many people are in each state and we know how many cows are in each state, we can probably figure out how many cows there are per people. And we can probably do that in our GIS, okay? And we'll learn how. Well, we can definitely do that in our GIS. I'll show you how. And which state has the most cows? Well, if we know how many cows there are, we can figure out which state has the most cows. So we'll have that too. All right, so let's endeavor now to create a project. We'll get started today, and we won't finish. And we'll start a project to study our cow questions, and we'll start gathering our data to try to answer these questions. Okay. All right. So I've got ArcGIS open. Let's start a new project. What am I in right here? I'm in a different project I was working on. We'll start a new map project, and I'm going to call it, oh, wrong keyboard, Cows of America. All right, Cows of America. Okay, and let's see how things look on the live stream. Looks pretty good. Okay, so I've created this brand new project, and if we look at our folder connection, it created a folder connection to the folder where the project resides. It created a default database to contain stuff about cows of America, but there's nothing in there right now because there's nothing in our map. So I wish I gotta figure out a better way to skip back and forth between the webcam and my monitor. But we want to find. So let's start by finding polygons. We want to find vector data, polygon data that gives us the shape of the 50 United States. Okay, and you know there's lots of strategies you could go here. You could say, well, let me go out to the internet, you know, do a Google search for a shape file for the 50 United States, or a geodatabase containing shapes of the 50 United States. You could try to you know, look through the databases that were provided with your textbook. There's also a tremendous resource on the web that's directly linked to ArcGIS Pro, and this is these are resources that are posted on ArcGIS Online. And so what you can do is in ArcGIS Pro you can search this online repository, and then you can import stuff from this repository into your map. All right, so let's do that approach. And so the way you do that is you go to Map, go to the Map tab, and you select Add Data, and add data to the map. And so this little Add Data window pops up. And what we want to do is, one of the options over here is to search through a portal. And let's search, let's start with the Living Atlas. Let's search the Living Atlas. And up here's a search box. And let's just search for U.S. states and see what we get. Well, there we go. U.S. states generalized, and it's a feature layer, and it's hosted on ArcGIS Online. So let's do that. Let's open this up. Wow, that's exactly what we needed. Okay, so now we have polygons for the 50 United States, including Alaska and Hawaii. All right. So it's a tremendous resource to go out and search the world of ArcGIS Online and the what they call the Living Atlas, which is a more, I guess that's a curated collection of maps that mostly raster data, I believe, that Esri curates. So there's something important to know about this. Let's look at the attribute table, and I'll come back to that. Okay, that thought I was about to have. So right click on this and look at the attribute table. We've got a column for state name, a column for abbreviation, region, population, white, black. I don't know what that is. Asian. Lots of different columns for different ethnicities and races. Demographic data. So there's a lot of data in here, including population data in 2017. Well, that's cool. We don't have to go searching for population data because it's already in this map. But there is a problem, So we want to. Unfortunately, this map doesn't have a column for number of cows. Okay, so we're going to have to attach. We're going to have to go out and find data about cows, and we're going to have to attach it to this attribute table. All right, but so we got to do that. But if we look at this attribute table, it's interesting. So you can go here, and you see that some of these features are grayed out. Like I can't add any fields. I can't do calculated columns. And the reason that it's like this is, remember, this is a web resource. It's not, right now, it's, I've linked it to my project, but this web resource is still hosted out in the cloud. So I can't modify it. I can't modify the data. I can change the way it looks on my map. I can change the symbology, but I can't change the values it has in the attribute table. Okay? But we want to be able to do that. So what we're going to do is we'll make a copy of this layer, the data that is being shown in this layer, into our local geodatabase. Okay, so this is how you do that. So if I right click on this layer and go to the data menu, one of the options is export features. And see, this says convert a shapefile or geodatabase feature class to a shapefile or geodatabase feature class. So we're going to convert one thing to the same thing. Well, we're exporting it. The window pops up. We're going to export this into our local geodatabase called Cows of America, which is over here. Okay. And let's call the output USA states local, something like that. And I'll click OK. And it's running, good, no errors. And you see what happened is now, over here, refresh this view. Now Cows of America, the geodatabase that's in my project folder on my local computer, has this feature class in it called USA States Local. And over here in my map contents, now I have two layers. One called US States Generalized, which is the hosted layer that's still out there in the cloud. I'm going to remove it. And I have USA States Local, which is linked to this feature class, which is sitting on my local computer. And now if I right click on this and look at its attribute table, okay, now we see that it's got the same data, but it's editable. I can add fields, I can add calculated columns, I can do those things. Okay. All right. So we have our shape files. We have our polygons for the states. We have our population data. And next thing is, let's find our cow data. You might be like, well, who's the authority on counting cows in the United States? And I would be, well, it's probably the USDA. And in fact, it is. There's, let's see, what's it called? It's called the National Agricultural Statistics Service, NASS. I think that's what it's called. Let's see. Where's Chrome? Wrong keyboard. NASS USDA. Yep. Yep, the National Agricultural Statistics Service. Yep. And so this is your tax money at work. There is, our federal government employs lots of people to keep statistics on agricultural production, and that includes livestock. So you can dig down into, and so this is what you should be thinking about a little bit at this point, is at the end of the semester you're going to be doing a project, and part of that is formulating a question, and then then you got to go out and you got to find data to help you answer that question. So you got to start thinking about where could your data sources be at this point. And so the USDA's NASS has all these data and statistics, and you can go to data about livestock, and you can do these queries, animal totals. Let's go to that's not what we wanted. Let's go to crops and livestock and animals. Shoot, that doesn't look right. Whoa. They do a census of. Okay, well, I'm not going to waste too much time digging around in there and for trying to find it again, because I did find it. And so what they have is a database that you can query, and I exported some data from the database. So let me show you what that looks like. Just give me a second here to find it. Here, I'll show you my desktop. Okay, so you should see I'm in File Explorer, and I'm going to, let's see, course documents, GIS. Here we go. Let's see, let's open with Excel. All right, so Let's resize a little bit here and zoom in a little bit, and we'll see what we got. So what I was able to do was do a query of this database, which is a count of cattle, including calves, an inventory of cattle, including calves, in each of the states for the year 2020. It was taken on it's an inventory that was dated the 1st of January. So the state of Alabama had 1,310,000 cows, and Alaska had 17,000. So I've got a row for each of the states, including, nope, not including. I thought I might have District of Columbia here. I wonder if there's any cows in Washington, D.C. So this is just the 50 states, not including D.C. All right. So I have data on cow populations, but it's not in my GIS yet. So I've got to bring it into my GIS. All right, so let's do that. Whoops. Okay. So let's see. How should I do this? There's usually a number of ways you can do things. Why don't I add a folder connection? So I'll add a folder connection to my folder called cattle inventory. So this is the folder that contains the data. So if I click there, you'll see there's two CSV files. That's comma separated values files, and there one is we won't actually need this. Actually, we will. Let's use that one too, but we'll get to that. This is the CSV file that we just looked at in Excel, containing the USDA NASS cattle inventory data for 2020. I'll right-click on it and click Add to Current Map. All right, so it came over here. Close that, and it's added a new tab, a new section under my contents menu for standalone tables. So I can right click on this and click open, and you see the same data that we were just looking at. All right, the column that has the cattle totals is labeled value, and then there's a row for state, and then there's a row for state ANSI. I can't remember what ANSI stands for. It's a national standard for American National Standards Institute. It's a standard of indexing various things, and so there's a standard for indexing states alphabetically. Alabama's got ANSI state, label 1. Indiana's 18. So this is data that we can use, but this data doesn't have it's not linked to any geographic representation. It's not linked to my polygons for the states. So that's what I got to do, is I got to take this table and I've got to merge it with the attribute table for my US states, and hopefully map things correctly so that the cattle data for Alabama gets attached to the row in my attribute table for Alabama and not some other state. Okay, so I need to do that, and it's the only way that this is possible is if there's a common index between your data file and your attribute table. So let me open both of them up and we'll take a look, and I'll show you what I mean here. So I'll open this up, here's my cattle data, and open up the attribute table, put it up here. Okay, so we can look at them at the same time. Make it a little bigger. Okay. Oh, well, there it docked itself. All right. Okay, so in the top, the table up here, this is the attribute table for my, associated with my polygon feature layer for the United States, and down here is this data table for the cattle values. So what I mean is, if we look at these, the columns, what I'm looking for is a column in both of these tables that can be mapped together. Okay, so man, how else can I say this? I'm looking for a common value in the row for Alabama in the attribute table and the row for Alabama in the cattle data table. Okay, so I'm looking for a common value. So let's take a look at this. And you know, one thing that comes to mind is, well, maybe the state names, because you know the row for Alaska is going to say Alaska in the name column, and down here the row for Alaska has Alaska in it. But we can't do that. Well, I guess we could change some things, but just natively here, this Alaska is not the same as this Alaska, because this one's written in all caps and this one's written in normal normally. Let's see what else. Well, we have this state ANSI number, and up here, if we look, there is a column called FIPS. All right, that's not ANSI, but FIPS. What's that? That's Federal Information Processing Standards. Okay, so it turns out that we're in luck here, because the number assigned to a state using this FIPS standard, Federal Information Processing Standard, is the same as the number assigned to the state using the ANSI code. Alabama is 1 in both of these standards. So we can map Alabama to Alabama. All right, but it's a little weird because here, let's look at the, if I right click on here and do, let's look at the fields. And the state ANSI data is of a data type called a long, and that's a numerical data type. It's a data type that can hold integer values, really large integer values, but it's a numerical data type. And if I go up here and look at the fields up here, state FIPS is a data type of text, which are characters. So we've got a problem, but we can solve it. And the problem is, we're not going to be able to map these text strings, even though they look like numbers. The computer thinks that they're text, they're words, to the numbers down here. But let's do something. Let's go up here and let's go to Fields, Add, and let's close that for now. And yeah, let's add a field to the U.S. states local attribute table, and we'll call it, let's see, we'll call it FIPS num, which is going to convert these FIPS from numbers into the same data type, a long. And I'll click Save up here. I'm gonna close these out and open it again just so it looks nice. Okay, so I've created a new column here. Should be all the way here at the end. See, FIPS num, and there's nothing in it. I just created a blank column, but I've created a place for something to go. So right click on this, and I'm going to do calculate field, because I want to calculate the values here based on values in another column of my attribute table. And so in here, I'm going to say that this is equal to the values in the FIPS column, which is referenced then down here, but I want to convert it to a number. So I'm going to do some Python here, and I know in Python the function float, if I do this, it'll convert the string 0, 1 into the number 1. And let's click apply. Okay, and it did it. So let's go over here. So in this first row, the FIPS number, the FIPS value is the character string 02. And I've converted that to the number 2. And then it's done this for all of them. All right, I'm going to save my project here. So let's take one more step today, and then we'll call it a day. Okay, so the next step is, let's now take this table with the cal data and merge it with the data about states. Okay. All right, so what we're going to do that is, if you right click on this layer, one of the options is joins and relates. So what we're going to do is we're going to add a join. We're going to add a join. So I'll click that. And the input table is US states local. And we're going to join based on the values in this column we just created, FIPS num. And we're going to join the data in the USDA NAS state cattle inventory spreadsheet, which is open. And in here, the join table field is called state ANSI. So what I'm telling you is I want to join US states local to USDA NAS state cattle inventory. And I want the join to happen so that there's a correspondence between the data that has the same FIPS num in the one table and state ANSI number in the other table. And then I'll click OK. And it was successful. No errors. So let's see. So the first row here is Alaska. And if I scroll over, I should see tacked onto the end here, yep, here it is all that cal data with the value right there. All right. So at this point, I can make a map of cows in each state. Let's do that. So I'll right click on this this layer and I'll do symbology. And I don't want a single symbol for all the features. What I want is graduated colors. Let's yeah, let's do that. Yeah, let's do graduated colors for now. And let's keep the defaults, natural breaks, 5 classes. We'll keep the default, and let's close this. And let's just take a look here. Okay, so so here you have, you know, the light green is not a lot of cows, and the dark blue is a lot of cows. Okay, so looking at this map, this is called a choropleth. It's hard to say. Choro, C-H-O-R-O, pleth, P-L-E-T-H, choropleth map. And a choropleth map uses this strategy of colors to communicate information visually on a map. So the color coding here is telling you information about the number of cows. You know what? I think I forgot this. As population, actually. I forgot to do something. I forgot to change. So it's showing 2007 population. Thought so. I thought there were more cows in those other states. So what I want to visualize is the value, which is cows. Okay. So Texas has a lot of cows. You can change this from number of cattle. Texas has a lot of cows. West Virginia, not a lot of cows. Nevada, not a lot of cows. California. New England doesn't have a lot of cows. Okay, but we've succeeded at visualizing how many cows are in each state. All right, so I'm going to save my project, and we'll pick this up on Friday. And let me check the live stream first. Let's see. If there is a no column in common, do we have to find new data that does match? So Frankie, this is an important question. Frankie's saying if there's no columns in common and you can't do some sort of manipulation to make them the same, so it's kind of like a mass where you're taking one set of data and you're merging it to the other so that the values in one of the columns are equivalent. That's how the join is the word that they're using in ArcGIS, is figuring out which data belongs in each row. So one thing you can do, with the United States, there's only 50 states. So you could do some manual data entry in a table. To our benefit, the people who do data collection have figured out a long time ago that there's a lot of benefit to having some sort of standard coding when it comes to, or indexing when it comes to collecting data. So I think you'll be surprised at how often there is a coding scheme worked out that allows these types of joins to be accomplished. So if there isn't a column in common, you might have to do some hand entry of data. But for like really, really large data sets, see if I can think of an example. I was trying to think of something I actually have done. There is, well, I worked on a map a few years ago where I was trying to visualize surface mining in West Virginia, and well, in that case there were only 50. Well, not even 50. I don't remember how many counties there are in West Virginia, but I was trying to generate a choropleth map of West Virginia showing surface mining activity over the years. It's like animated. And I do remember that my shapefile, the file that contained the polygons for the counties in West Virginia, did not have a coding that matched the coding for the surface mining activity. And so in that case, all I did was said, well, I'll just go find another file that does have the right coding, and it wasn't that hard. Just do a search for West Virginia County shapefile, and you could find lots of different options. So you don't always have to go searching for new data if it's not set up for an easy join. But sometimes it is the easiest thing to do, just to go out and find a different data set that suits your needs. All right, so I'll see you guys tomorrow. I haven't checked the sign-up sheet, but make sure you sign up for either the 9 to 11, 11 to 12:50, or 1 to 3 session tomorrow. Beginning next week, the lab will be available on Tuesday afternoons from 1 to 3 as well. So I'm trying to expand access for you. And I hope to see all of you tomorrow at some point during the day. And if I don't see you tomorrow, I'll see you Friday. All right? And enjoy the rest of your day.